Hello everyone, we are our students from GM University 4th SEM CSE branch. We are here to present a project on the KNN Decision Tree Navy Base Prediction Spending category, guided by Sheikh Dawood Sir, Assistant Professor, Department of Computer Science and Engineering. Our theorem is KNN nearest and decision tree Navy's base. I am giving introduction about this project. Customer segmentation helps companies understand and target different types of customers. Instead of treating all customers the same, businesses can group them by behavior, in this case, how much they spend. This project aims to predict the spending category like low, medium, high of a customer using machine learning. The three models compared are firstly K nearest neighbors, a distance based algorithm, then decision tree. It is used a rule-based tree structure that splits data based on features. Now, Naive Bayes, a probability-based classifier that assumes feature independence. Our goal is see which model perform best and under what conditions each model is suitable. Now, dataset discussion. The dataset is from Kaggle Small Customers datasets, which includes the terms like customer ID, gender, age, annual income, spending score. In customer ID, a unique identifier removed for training because it doesn't affect spending behavior. Gender converted to numbers, male, female, so algorithms can process it. Age, the age of the customers. Annual income, the income of the customers in thousands. Spending score based on shopping habits, loyalty, etc. This is the target variable. Target class mapping are 1 to 40 low, 41 to 70 medium, 71 to 100 high. Now, data pre-processing. Preparing the data for the models. A dropped customer ID, not helpful for patterning, learning patterns. Encoded gender like machine learning models need numbers, not strings. Feature scaling, age, income, and score are scaled using standard scaler to bring them to the same range. This avoids base from larger numbers like income. Train, test, split. This is used to the data set is divided 80% of training the model and 20% for testing its performance. Now, my friend Bhumika will explain about this.
Model implementation, how each model works. KNN, that is K nearest neighbors. Classify a new customer by looking at closest existing customers' neighbors. If K is equals to 5, the model checks the 5 nearest neighbors based on Euclidean distance. Whichever category, low, medium, high, is the most common among these 5 becomes the predicted class. Pros: simple and effective for small datasets. Cons: slow for larger datasets, sensitive to irrelevant features or noisy data. Decision tree: the model creates a tree where each node splits based on the best features. Splitting criterion uses entropy, a measure of uncertainty. It chooses the features that gives the most information gain, reduces entropy the most. Flow from the root to leaf. The tree asks questions like: is income greater than 50k? Is age smaller than 35? Spending on the answers, it it routes you to the class low, medium, high. Pros: easy to understand and visualize. Cons: can overfit, that is, it learns the training data too well and may fail to generalize. Navy Bayes or a Gaussian NB. Based on Bayes' theorem, assumption, it assumes all features, age, income, gender,
Which
are
is
independent,
always
true, but still gives surprisingly a good result. Gaussian NB assumes features are normally distributed, bell-shaped curve, which is common in real-world numerical data. Pros: fast works well with high-dimensional data. Cons: performance can drop if features are strongly dependent. Now, my friend Prajwal will continue.
Now I am explaining about code. Here, import pandas SPD from scikit-learn dot model selection import, train test split from scikit-learn dot preprocessing import, label encoder from scikit-learn dot neighbor import, k-neighbor classifier from scikit-learn dot naive Bayes import, Gaussian NB from scikit-learn dot tree import, decision tree classifier from scikit-learn dot matrix import, accuracy score classifier classification reports. It explains that here we are handling data, split data into training testing sets, convert text data into numbers, train three machine learning models like KNN, Navy Base, and decision tree, evaluation how well the models perform. Next, here df is equal to pd dot read csv. That is here we are explaining that about we are loading about CSV file that contain information about mall customers like gender, age, income, and spending scores. Next code def get category score. If score less than equal to 40, returns low. Else if score less than equal to 70, returns medium. Else return high. df spending categories equal to df spending scores 1 minus 100 dot apply get categories. Here we are using if else statement, that is if we use your if we use you are converting the spending score, that is 1 to 100 into a new column called spending category, that is score 0 to 40, it will give low, or from 41 to 70 it give medium, score 71 to 100 it give high. Next, df gender equal to label encoder dot split transform df gender. Here we are taking your changes gender from text to numbers, like male implies 1 and female equal to 0. Next, x equal to df gender age annual income case, y df spending categories. Here we are picking the inputs x like gender, age, and income, and the thing you are trying to we are trying to predict is spending the categories. Next, x train, x test, x y train, y test, train test split. Here we are splitting the data into 80% for training to teach the model, 20% for testing to check how well it learning. Next, knn is equal to k neighbor classifiers, n neighbors is equal to 5. Knn dot fit x train, y train, knn equal to knn dot predict x test. Here, this code explains that KNN finds the 5 closest points to a new customer and predicts based on what their categories are. Next, in the code, NB equal to Gaussian's NB. NB dot fit X train Y train predefined NB equal to NB dot predict X test. This code explains naive Bayes uses probability to guess which category the customer fits into. Next, decision tree in DT is decision tree classifiers. DT dot fit X train Y train predict DT equal to DT dot predict X test. This code explains the decision tree ask X or no styles questions to predict that categories by step. Next, evaluate each models, like here the code is print accuracy score y test predefined knn, print classifications report y test predefined knn. For each model we print accuracy, how often it was correct, precision, recall f1 score, more detailed performance states. This ends the code. The summary of the code is we are building a mini AI that looks at a customer gender, age, and income, predicts whether their spending behaviors is low, medium, or high, tries this using 3 different methods, compares which method works best. Now I am explaining about the output of this code. Here KNN gives the accuracy of 66%, where precision recall F1 score support. Here the high is 67%, recall 100%, F1 80%, support 2%. Next, low is 0%, recall also 0, F1 also 0, support 1. Next, Navy base accuracies. It gives 66%, precision recall F1 score support. Here the high are 67%, 1, 100%, F1 score is 80%, support is 2. And low recall F1 also all are 0%, support all is 1. Next, decision tree accuracy 100%. Here a high is 100%, recall 100%, F1 score 100%, support 2. And low 100%, recall 100%, F1 100%, support 1%. Next, the summary of this output is we are tested three models in like KNN Navy bias decision tree to predict how much customers spend low, medium or high. We are test data had only three people, which is very small. Next, results. Karen got 2 out of 3 predictions right, that is 66.7 accuracy. Only predicted the high category correctly. Next, failed to predict the one low customers. Next, Navy bias. Same as KNN, like 2 correct, 1 wrong. It is also as it gives 66.7 accuracy. Also missed the low customers. Next, in decision tree, got all 3 correct, that is 100% accuracy. Predicted both high and low customers accurately. This is the our code explanation. Next, Prakruti will continue this.
Hello everyone. Now I am going to explain about the model evaluation. How do they perform? The models were tested using accuracy, percentage of correctly predicted spending categories, precision of customers predicted as high, how many actually were, recall of all actual high spenders, and how many were correctly predicted. F1 score, a balance between precision and a recall. Performance summary KNN 67% accuracy, decent but slow with large datasets. Decision tree 100% accuracy, perfect but likely overfitting. Naive base 66% accuracy, good, especially considering its simplicity. Conclusion. What do the results tell us? Decision tree was the most accurate but might not perform as well as on unseen data because of overfitting. Naive Bayes gave strong results, ideal for large datasets or when speed is important. KNN also did well but might not be practical for real time due to computational cost. Recommendation. When to use which model? Use decision tree if you need interpretability. You are working with small to medium datasets. You want rule based decision making. Use naive Bayes if speed matters and you are working with text data or large datasets and feature independence is not a major issue. Use KNN if you have a small dataset or if you suspect the class boundaries are non-linear and you can afford more computational time. Thank you.
Thank you, one and all.